Hi, today we're going to be working on lesson 14, session 3, using estimation with decimals. So the last couple of days we worked on estimating answers when we were adding and subtracting fractions. And so today we're going to be doing adding and subtracting decimals, but using estimation to check our answers for reasonableness. We're going to be working in our Ready Classroom workbook on pages 281 through 286. So go ahead and open up your Ready Classroom math workbook to page 281, and we will begin there. So we're going to read and try to solve this problem. So this problem says, Scott is conducting a science experiment. He has 3 7/4 liters of liquid A and 3 6/5 liters of liquid B. He pours both liquids into a container. How much liquid is in the container? Estimate and solve. Tell if your answer is reasonable. So this question is talking about Scott's science experiment, and he has some liquid A and liquid B. So what he's trying to find out is how much liquid does he have in the container since he poured both of the liquids into the container. And then the important information is that he has 3 7/4 and 3 6/5. So if we wanted to estimate, we could take both of our decimals. 3 7/4 is about, and then 3 6/5 is about. Now we could round both of those. We could round both of those to the nearest whole, which would give us an estimate that's pretty close. So if we wanted to round both of these values up to the nearest whole, 3 7/4 is about 4, because 7 is, if we put the door here, 7 is 5 or more up the score, which would make this be a 4. And then if we rounded 3 6/5 to also to 4, because this 6, if we drew our door, this 6 would round the 3 up to 4. Then we would have 4 plus 4, which equals 8. So he has about 8 liters of liquid. This is our estimate. So now we're going to go find out what is our actual amount to see if our estimate is reasonable. So you know how to add decimals. You can use your place value chart if you need a place value chart. Otherwise, you can go ahead and line up these two decimals by their place value, making sure that you line up your decimals. So we have 3 7/4 plus 3 6/5. 4 plus 5 is 9. 7 tenths plus 6 tenths is 13 tenths. I'm going to put 3 tenths down there and regroup 10 of my tenths to make a whole. 1 plus 3 plus 3 equals 7. He actually has 7 39 liters of liquid. So our actual answer is 7 39. Our estimate was 8 liters. Is 7 39 close to 8 liters? Yes, it is. So therefore, our answer is reasonable. Our answer is reasonable because our estimate was close to our actual answer. Go ahead and go to page 282. Now, here are 2 other ways that you could look at this problem, one using decimal grids and one using a number line. So you can picture an estimate of the problem using decimal grids. Both 3 7/4 liters and 3 6/5 liters are about 4 liters, because when you color them both in, they both are about 4 wholes. Do you see that? Now, these 2 are not all the way full, but they're very close to being full, so they're about 4. So an estimate of the sum is 4 plus 4, which we know is 8. The actual sum can be found by adding 3 and 74 hundredths plus 3 and 65 hundredths, which got us to that 7 and 39 hundredths on the last page. You could also use a number line. 3 and 74 hundredths plus 3 and 65 hundredths are both between 3.5 and 4. So you've got 3.5 here and 4 here. We could also round both of these down to 3.5 and add them together, and we would get, which would equal 7. So up here, this equaled 8. Here, if we added 3.5 and plus 3.5 equals 7, remember that our actual answer was 7 and 39. And so our actual answer here would be 7 and 39 hundredths. So an estimate of 3.5 or 3 and 5 tenths would also be a reasonable estimate because 7 is close to 7 and 39 hundredths. So rounding both decimals up to 4 or down to 3 and 5 tenths would both be reasonable estimates because they both are close to the actual answer. So go ahead now and go to page 383. So it says, looking back, let me autofocus, there we, maybe. All right, so looking at the picture it, why is 4 a good number to use for each add-in in an estimated sum? So both 3 and 74 hundredths and 3 and 65 hundredths round up to 4. So 4 is a good estimate. And we talked about that already as well. So here's what's really important about whether you're rounding up to 4 or down to 3.5. Is the actual sum of the measures of A and B, and picture it, less than or greater than the estimated sum? Why? So here's our actual answer, and here's our estimated answer. Our actual sum is less than, it's going to be less than 8, not less than 4. So our actual sum is going to be less than 8 because 8 was our estimate when we added 4 plus 4, because both liquids are less than 4 wholes. So since both of these amounts are less than the two numbers we rounded to, that tells us that our actual answer is going to be less than this answer. Now on the flip side, if we look at this, model it down below, why is 3.5 or 3 and 5 tenths a good number to use for each add-in in an estimated sum? So both 3 and 74 hundredths and 3 and 65 hundredths can round down as well to 3 and 5 tenths, which is an easy number to use when adding. It's super easy to go 4 plus 4 is 8, or 3 and 5 tenths plus 3 and 5 tenths equals 7. We can do that in our heads. So in this case, so when we rounded up here, we got a number that was too high because we rounded both numbers up. Down here, we rounded both numbers down. So we got an estimate that was too low because since we rounded both of these numbers down, we got an estimate too low. Now, the closest would have been if we rounded 1 up to 4 and 1 down to 3.5, and then we would have got an estimate of 7.5, which would have gotten us really close to our answer. But that's okay. That's not what we're working on today. So we know that the actual sum will be greater than the estimate because 3 and 74 hundredths and 3 and 65 hundredths are both greater than 3 and 5 tenths. So since both of these numbers are greater than 3 and 5 tenths, our estimate will be 7, but our actual answer will be greater than, because these two numbers are greater than 3 and 5 tenths. So explain how you can check to see if a decimal sum or difference is reasonable. You can round decimals to numbers that are easier to work with. If your estimate is close to the actual answer, your estimate is reasonable. And then finally, after you're done writing that down, you're going to reflect. The strategy I like best for estimating with decimals is, do you prefer using a method where you're going to use the decimal grids? Do you like using the number line? Or do you like just rounding to the nearest whole or half? And I would just call this like the standard method. I don't really know. I think that it was closer to this method here. So you're going to tell me the strategy you like best. And then you're going, and today you don't need to tell me why. I'm giving you an easy one today. Just tell me the strategy you like best. When you're done, go ahead and go to page 284. All right, on page 284, our first problem that we're looking at says Sean has 12 and 6/10 meters of garden netting. He needs 15 and 85/100 meters to enclose his garden. How many more meters of netting does Sean need to buy? Estimate to tell if your solution is reasonable. So first we're going to estimate. So he has 12 and 6/10. He needs 15 and 85/100. We need to figure out how much more he needs. So we're going to take our greater number and subtract our lesser number to find out how much more he needs. So we're going to go ahead and start with that 15 and 85/100. And then we're going to subtract 15 and 85/100 and then subtract 12 and 6/10. So to do this, what I think we should do is round both of these up to the nearest whole number. So 15 and 85/100 rounds up to 16. 12 and 6/10 rounds up to 13 because that's rounding both of these to the nearest whole. And so 16 minus 13 is 3. So he needs about 3 meters of netting. Let's see what the actual answer is and see if we were close. 15 and 85/100 minus 12 and 6/10. Go ahead and put in my placeholder 0. 5 minus 0 is 5. 8 minus 6 is 2. 5 minus 2 is 3. 1 minus 1 is 0. So Sean really needs 3 and 25/100 meters of netting. Was my answer reasonable? Yes, reasonable. Because 3 is very close to 3 and 25/100. It's awesome to use estimation to check for reasonableness because that helps us find if we made a mistake. If our estimate is really far away from our actual answer, that means one of two things. We may have solved this problem incorrectly, or we may have estimated incorrectly or estimated not to a number closest. So it's always good to estimate to check for reasonableness to see if your answer is close. Number 8 says Erica wants at least 6 kilograms of apples for a recipe. So she wants to have at least 6 kilograms of apples. So she picks, here I'll circle the important information. She picks 2 and 56/100 kilograms bag of red apples, 1 and 18th kilogram bag of green apples, and 2 and 79/100 kilograms bag of yellow apples. Does Erica need to pick more apples? So what I'm thinking here is that since we're trying to see if she has at least 6 pounds of apples, if we round all of these estimates down and then add them together and we get at least 6 pounds of apples, we're going to be good to go. And we will know that Erica will either does not need to pick more apples or does need to pick more apples. So watch what I am thinking here. 2 and 5/56 is very close to 2 and 5/10. Okay. 1 and 18/100 is close to 1. Because I'm rounding this down to 2 and 5/10, this down to 1 whole, and then I'm going to round 2 and 79/100 also down to 2 and 5/10. So I've rounded all of these numbers down. So she actually picked more than I'm going to estimate that she picked because I rounded all of my numbers down. So 5 plus 5 is 0. Bring my decimal straight down. And then carry my 1 because I'm regrouping my 10 tenths into a 0 tenths, and 1 whole. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 2 is 6. So already I estimated all of these numbers down, saying that these estimates are as though she picked less than what she really picked. And she needs 6 kilograms, and we got 6 kilograms. So she actually picked more than she needs. So Erica does not need to pick more apples because she already has 6 pounds, and that is me estimating. Just for kicks, I'm going to go ahead and add all of those together to show that she does actually have more than 6 pounds. 8, let's do this. 6 plus 8 is 14. 14 plus 9 is 23. 2 plus 5 is 7. 7 plus 1 is 8. 8 plus 7 is 15. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 2 is 6. So she actually picked 6 and 53 hundredths pounds of apples. So it says here, use estimation only to decide. Well, we decided before we checked our work, but she really didn't need it. Okay, now finally for number 9. Number 9 says, Vin is having lunch at a cafe. He has $15 in his pocket and has already ordered a sandwich for $8.57 and a drink for $2.34. Vin also wants to buy a side salad for $5.25. Does he have enough money? Estimate or find an exact answer to solve. Since we've done a lot of estimating today, we're going to go ahead and just solve this problem. So we know he has $15. First, we need to find out, he already ordered a sandwich and a drink. So let's go ahead and find out how much he already spent. So his sandwich was $8.57, his drink was $2.34. 7 plus 4 is 11. 1 plus 5 is 6 plus 3 is 9. And then 8 plus 2 is 10. So he has already spent $10.91. He has $15 in his pocket. So now we're going to subtract the $10.91 he's already spent from his $15. So I cannot take 1 away from 0. So what I tell everyone in my class is to think about this number as 150. And we're going to change this, we're going to borrow 1 from 150 and make this 149, and then regroup and make that number 10. 10 minus 1 is 9. 9 minus 9 is 0. Bring that decimal straight down. 4 minus 0 is 4. 1 minus 1 is 0. So right now, he has $4.09 left. Does he have at least $5.25 left to buy a side salad? No, he does not. So Vin does not have enough money because he needs $5.25. He only has $4.09. You're going to go ahead and finish pages 285 and 286 on your own. If you have any questions, email your teacher. Otherwise, we'll see you next time.